Hey, how's it going, Wildcats? So I'm here. I'm going to talk to you a little bit about the unit quest for tomorrow. First and foremost, I've got a deal for you. All right. It's only announced here. So if you watch the video, then you might know that there's a deal. If you don't watch the video, sorry about your luck. All right. But I'm going to post the video and I'll link it into the spreadsheet here in a little while once it uploads to YouTube. The deal is I will purchase your equation sheet from you. So you won't be able to use your equation sheet, but I'll give you a free point on the quest. So it's going to be out of 12 questions. I'll give you a free question out of 12 if I can buy your equation sheet from you, where you don't get to use your equation sheet. What that means, just to make it fair on your end, you need to know all three of the kinematics equations. You need to know Newton's second law, F equals ma, and you need to know the friction equation. F of the force of friction is less than or equal to mu Fn. And of course you got absolutes and stuff like that in there. But yeah, I'll purchase that from you. Those are the only three equations. Sorry, those are the only 5 equations that you could possibly need for this exam. All right, that's on the equation sheet anyways. So, free point. Anyways, or purchase point rather. Anyways, I've got the test in front of me, so I'm going to go ahead and talk to you as I investigate through it. And this is in no particular order, but I'm looking at one question right now, and I see really a Newton third law question. All right, so really how you answer the question is with Newton's third law. If you apply Newton's third law appropriately, then you will answer it correctly. So that's all I'm going to say about that question. Next, this question is going to require a free body diagram, or it'll probably require a free body diagram. It has no picture with it, but a picture would be helpful. Free body diagram would be essential. And then from that free body diagram, you're really going to have to pay attention to the directions of the variable forces that are present. And so you're going to have forces in the vertical and the horizontal, and they might even act in different locations. You need to draw all the forces everywhere, and if the object is not accelerating, then you should know something about the sum of the forces in the x and or the y direction. That's all I'll say about that one. Next question. Looks like they give you a picture. The answer choices have forces in them. It also has sine and cosine in them, and FGs, FNs, and FFs in them. So looks like you're going to have to wrestle with some forces at angles. You're going to have to wrestle with gravitational and normal forces and frictional forces all in that question. And like I said, the answer choices just have symbols in them, including F's, FGs, sines, cosines, normal forces, and frictional forces. So that's that question. Moving forward, I see the answer choices are free body diagrams for this question, so maybe they're important. Next question. Oh, it's a trio of questions, all about the same thing. Well, the same scenario anyways. What can I say without giving it away? Well, Batman. Let's say from the FBD stations activity, where you walked around the classroom and you drew free body diagrams for the different stations, Batman was located in an elevator. Instead, let's put Superman on top of Batman, so like a shoulder ride. Cool. So you got Superman up here, Batman holding Superman in the elevator. send them through a bunch of different scenarios and draw Superman's free body diagram, Batman's free body diagram, uh, draw don't forget about Newton's third law, action reaction, and see if you can work in Newton's second law somehow. Alright? See if you can work in Newton's second law. So you could express a force, one of those forces in the free body diagram, or multiple forces in the free body diagram, in terms of M's, A's, and G's. Cool? That's really vague, but mess around. Alright? Next. No tips on that one. Got two questions here. Let's see here. Make sure you know how we could figure out the net force acting on something if it's on the ramp. And what if it was on a ramp and it was an Atwood? So what if you had a ramp and a pulley with a mass over here? This guy right here, what's its free body diagram look like? Throw in some friction on this bad boy as well, and see if you can come up with a net force acting on this from something like that. And if you wanted to get even more challenging, why don't you have that Atwood, hanging mass over here, free body diagram for this boy, free body diagram for this boy too, just for fun. Strings pulling up, and then make somebody else push down at like an angle this way, if that makes sense. And so just funk it up a little bit, add some extra force vectors for whatever reason. Put somebody behind the box and like pushing, but they're not pushing perfectly horizontal, pushing at an angle or something like that. And see if you can figure out the net force acting on it, or derive the net force acting on it. Cool. Ain't gonna tell you nothing about that one either. Newton's third law. Newton's third law and Newton's second law. And this guy right here. It's like Newton's second law and friction together. And then that guy right there is a classic, and I'm not telling you nothing about that one either. So it's gonna frustrate students, but so I wanted to frustrate you a little bit. How do you be successful on it without giving it away? You need to put yourself in the perspective of the object, and then remove yourself from the perspective of the object and put yourself in a different perspective. And if you're able to shift your perspective from one place to another place to another place, and think about the physics, the dynamics of what's taking place, you'll be successful on this question. But it is challenging. It's hard to conceptualize. Some kids are going to get it without too much difficulty, and other kids will be in May and you'll still be asking me about this one, because it won't all the way make sense. But it's actually a pretty easy question. Anyways, that's all I got for you right now. If I had to like prompt you on any question, I would say, would Newton's first law help you? Would Newton's second law help you? Would Newton's third law help you? Would a free body diagram help you? Would friction help you? And like maybe SOHCAHTOA. would SOHCAHTOA help you? And- but those 5 things, physics-wise, are the heart and soul to doing extremely well on this dynamics assessment quest. If you know those 5 things and you're willing to apply those 5 things any way, shape, or form, you'll be met with success, and I can assure you of that. Mathematically, the hardest part is Newton's second law, having multiple forces with different directions that aren't along an axis, summing the forces in the y direction, summing the forces in the x direction. That's really the complicated math where you get some weird derivations. Outside of that, if you're able to conceptualize it right, you'll be rocking. Okay, that's all I got for you right now. Good luck, study hard, talk to a friend, discuss with a parent, all of those things that make you successful. That's all I got for you right now. Make it a great day or not, the choice is yours.